In this section, we are going to look at solving inequalities. So we looked at equations, which means it has an equal sign. These are inequalities. So you can use everything except an equal sign. You should be familiar with these particular symbols. You have your less than symbol, your greater than symbol, your not equal to, you're less than or equal to, and you're greater than or equal to. And so you need to review those real quickly as we are going to start solving inequalities using those symbols. So let's look at some of the properties, and a lot of these will seem very familiar compared to our equation properties. The first one is specific to just comparing numbers. Every comparison of two real numbers, A and B, has one of three results. It is that A is less than B, A is equal to B, or A is greater than B. So if you compare any two numbers, one of those three has to be true, is pretty much what this is telling you. Now, let's look at the transitive property of inequality. This is similar to the equality one. If A is larger than B or greater than B, and B is bigger than C, greater than C, A is greater than C. And that is true for all of your inequalities. Any value that makes an inequality true is called a solution, just like in an equation. If a number makes an inequality true, it is a solution. Now, inequalities can have more than one solution and very often do. Addition property, if you have an inequality, you have to add the same thing to both sides to keep that equality true. Multiplication, if you have an inequality, you have to multiply both sides in order for that to remain true inequality. Here's the difference here. If you're multiplying or dividing the inequality by a negative number, so this is specifically to multiplying or dividing by a negative number, then in order to keep it true, you have to reverse that inequality sign. And so that is a little bit different. So when you're multiplying or dividing and it is an inequality, you have to watch for those negatives. Now, it's only what you are multiplying or dividing by. So it is only the number that is with your variable when you move it across the equal sign that we will flip that sign. And we'll do some of these examples. So let's look at this first one. Solve this inequality. We are going to treat this exactly the same. We are going to look at this and say, move all my numbers to one side, my variables to the other. So because I only have one variable, I'm going to move this 12 over, doing the opposite. It was a positive 12. I'm going to move it over. Leave this 4x alone. Leave this inequality alone. And now I have a negative 4 over here. Now, I am not dividing by a negative. I am going to divide by the number with my x, and the number with my x is a positive 4. So I'm going to divide both sides by 4. On the left-hand side, I have the x. I do still have a less than negative 4 divided by positive 4 is negative 1. So let's look at graphing this. You always want to start at this number. So I'm going to find negative 1 on my graph. Then I'm going to look at my inequality. If I have just a less than or a greater than, I'm going to use an open circle here, open. If I have an or equal to, I am going to use closed. This tells me that if it's open, it does not include the number. If it's closed, it does include the number. So in this case, it is open. It does not include the number. So I'm going to do an open circle on that negative 1. Then I want to say, is my variable smaller or bigger than negative 1? Well, in this case, my variable is smaller than negative 1. So I want to shade everything that is smaller than negative 1. And so I'm going to shade that direction. And I do want to put an arrow on the end showing that it keeps going on infinitely. All right, let's look at a little more difficult of a problem. This is one that it requires distribution. It has variables on both sides. We are again going to approach this just like we did the equations. We're going to do our distribution. We're going to combine our like terms, move our variables to one side and our numbers to the other. So let's go ahead and use our distribution. We're going to say 2 times x and 2 times 9. and then negative 6 times x and negative 6 times 2. Leave this alone for right now and leave that other side alone. On the left-hand side, combine those like terms. 2x and negative 6x, negative 4x. 18 and negative 12 is 6. Remember, we don't change signs when we are just combining like terms. We only change signs when we are moving it across. So in this case, we're going to move the numbers to one side. I am moving the 6 across, so I am going to change that sign, make it a negative. And so over here, I have negative 10. Same thing with this x. I'm going to move the x's to the other side. It was positive x over here. I'm going to subtract an x. Negative 4 minus negative 1, negative 5x. And don't forget that you do have an inequality sign, so move that down, greater than or equal to. So I distributed, combined my like terms, moved my variables to one side, numbers to the other. Now I'm ready to divide. So now I'm dividing by the number in front of the x, negative 5. Here, I have gotten my x by itself. However, I divided by a negative 5. So this is the situation where I am going to flip that from greater than to less than or equal to. And then I'm going to do my division. Negative 10 divided by negative 5 is a 2. And so that is how I'm going to solve this larger equation. No, I'm going to start at that 2. So find the 2 on your graph. Determine if it is open or closed. This one is going to be closed. And then is this smaller or bigger than that 2? It is going to be smaller than that 2. And make sure you add that arrow on the end. So you might have some special cases where you have no solution or all real numbers. And that is just whether you get a true statement or a false statement sometimes. So let's look at two of those. So on this first one, if I were to distribute, I'm going to get negative 6x plus 27 less than distribute negative 6x minus 8. What happens in these cases is as I move my variables to one side and I move my numbers to the other, I get 6x and negative 6x. Well, that is 0, and it has canceled out here. Less than negative 8 minus 27 is negative 35. Well, 0 is less than negative 35. That is not true, ever. And so when you get something that is not true, your answer is the empty set, no solution. And you may write it either way, no solution or that empty set symbol. So that's one scenario. It's when you get rid of all your variables. So all your variables end up zeroing out, and you have a false statement. And that is no solution. Let's look at the next one. When I distribute 15x plus 30 minus 15x is greater than or equal to 0. Well, when I simplify 15x and 15x, that's 0. And I have 30 is greater than or equal to 0. Well, that is true. So the other situation is you get rid of all of your variables, but you have a true statement. That is all real numbers, or the real number set symbol there, or you can say all real numbers. And so that is your solution for this one. Every single number is going to make that statement true. So let's look at one final problem, a word problem here involving inequality. So working at a small boutique, Becca earned $6 an hour plus 5% commission on clothing that she sells. How much must she sell to the nearest dollar to make at least $200 during a 20-hour work week? Right? So she makes $6 per hour and she is working 20 hours. All right. So just that part of it is going to be $120 in her pay. Now we add to that 5%. Well, remember, we're going to write percentages as decimals. So 5% on what she sells. Well, we don't know what she sells. In fact, it says how much. That's where my question mark is, which means that's where my variable is. Now, so this is what she's going to get paid. She's going to get paid $120 plus 5%. And she wants to make at least. So does she want her pay to be less than 200 or does she want it to be more than 200? Well, she wants to make at least, which means she wants to make more than or equal to $200. And now we have an equation we can solve. Now you could get rid of that decimal if you wanted to, or you can just solve this equation. You want to get rid of the decimal. At this point, remember, you can move it two places. Move everything two places. And you have 5x is greater than or equal to 8,000. And then you can just divide that. So when you divide, you're going to see that she has to sell a certain amount of clothing in order to make that much. She must sell at least $1,600 in clothing in order to make at least $200 in her work week.